formed at near sea level, but it's since been raised by nearly 2 kilometers above sea level. The whole region has been updomed, mostly around here. And one possibility to explain the initial formation of the Red Sea is that this bulging of the crust caused stretching across the line of the Red Sea and the development of a trough or graben. Or perhaps the two plates moved apart before the uplift happened, or perhaps there are elements of both processes. But one way of tackling this problem is to look at the sediments. For the history of any stretch of water, the Red Sea included, is recorded in the sediments that are deposited there.
During the last 20 million years, this area has certainly been one of considerable instability. But prior to that, for 500 million years, this was a very stable area. During that period of stability, terrestrial sediments were deposited over the whole of the area. These terrestrial sediments were interbedded with marine and intertidal sediments, which were the result of transgressions coming up from the north in this direction here. Terrestrial sediments are very similar to the millstone grit in Britain. Unlike the millstone grit, they are a facies deposit. That is, they vary in age from place to place. These deposits are called the Nubian and were laid down in large, flat, depositional sheets, sure that rivers must have been draining this area here for hundreds of millions of years. These braided rivers flowed from an upland region in the south here, northward into an ocean up here. During the lower Cretaceous, a marine transgression covered the whole of this area here, depositing over Sinai limestones. Further south, towards the coastline, we find shale deposits. The best exposed outcrop is found at Quasir, and these shales, with plant remains, are interbedded with shallow water limestones rich in oysters and with phosphates. This is a clear indication that the coastline must have been fluctuating in this area here. Limestones continued to be deposited during the lower and middle Eocene, and these sediments stretched from the Tigris-Euphrates Valley in the east right the way across this properly. We need to look in detail at a cross-section along here. This is the section, and unlike Eocene chalks here and here. These are about 40 million years old. All these younger deposits, from the Oligocene gravels upwards, have been draped over the topography produced by the faulting along the margins of the Red Sea. And in deeper water, shales containing planktonic organisms were being deposited. All these features indicate a sea of normal salinity. For a number of reasons, the Red Sea must have been cut off at some time. And as the sea became isolated, evaporation caused sea level to fall. Salinity increased to about 10 times what it is normally, and halite was deposited. Each time this happened, a little less than 2 meters halite was laid down. But we find thin shale bands interbedded with the halite, so sea level must have risen again periodically. We know there's a total thickness of 5 kilometers of halite in the Red Sea Basin at the present time. This means that the process of filling and evaporation must have been repeated nearly 300 times. This process ended in the Pliocene, 5 million years ago, when the southern end of the Red Sea opened to the Indian Ocean. And shales with an Indian Ocean fauna were deposited over the whole of this area. This process continues to the present day.
Well, if Africa and Arabia were one until, say, 20 million years ago, as the sediments indicate, and if the coastline fit is still the best.
The distance between the two along the line of the fault is 105 kilometers. Now, elsewhere along the fault, we can demonstrate that the movement took place in two main phases. One relatively recent, within the past 5 million years, of 40 to 45 kilometers line. It was the almost perfect match in the configuration of the opposing coastlines which first drew attention to the possibility that the present 5 kilometers has occurred along the Aqaba Jordan Valley fault. The trouble is, such movement does not open the Red Sea to its present position. Something is obviously wrong. Perhaps our assumption of a tight coast-to-coast fit was in error.